So far in this course, you've learned different ways to manipulate data for different scenarios using functions, operators, and such. In this module, you will use these basics that you've learned so far and see how to manipulate data at an advanced level. You have learned that data in SQL Server is stored in rows and columns, but when writing reports, you may have to summarize the data and display it in a more understandable and user-friendly format. You may want to see some of those rows in your data as columns and vice versa. In this module, you will learn how to use pivot and unpivot functions to change the orientation of data from rows to columns and columns to rows. There may be some scenarios where you would need multiple groupings of data in the same select statement. You will learn how to use the grouping set subclause of the group by clause to do that in this module. Let's get started. In the first lesson, you will learn what pivoting is, what the different elements of pivot are, and how to write queries using pivot and unpivot. So, what is pivoting? Pivoting is rotating data from a rows-based orientation to a column-based orientation. Pivot rotates a table-valued expression by turning the unique values from one column in the expression into multiple columns in the output, which means it rotates a row to columns and aggregates when they are required on any remaining column values that are wanted in the final output. For example, take a look at the data that is displayed here. It shows the category and order year along with the values for quantity for each instance of a category order year pair. You can see that the category and order year are repeated. If you want to analyze this data, you can use the pivot function, and the data will be displayed as shown here. In the pivoting process, each distinct year was created as a column header, and values in the quantity column were grouped by category and then aggregated. The table results on the left is a partial result set, so the sums on the right result set will not exactly match. Now let's see what the different elements of pivot are to get a better understanding of how this function works. The T-SQL pivot table operator, which is introduced in Microsoft SQL Server 2005, operates on the output of the from clause in a select statement. To use pivot, you need to supply three elements to this operator: grouping, spreading, and aggregation. Grouping. In the from clause, you need to provide the input columns, and from those columns, pivot will determine which columns will be used to group the data for aggregation. This is based on looking at which columns are not being used as other elements in the pivot operator. And you need to provide a comma-delimited list of values to be used as the column headings for the pivoted data. These values have to be in the source data. You also need to provide an aggregation function to be performed on the grouped rows. Additionally, you need to assign a table alias to the result table of the pivot operator. For example, let's take a look at this query. In this example, order year is the column providing the spreading values, quantity is used for aggregation, and category is being used for grouping. Order year values are enclosed in delimiters like shown here to indicate that they are identifiers of columns in the result. Any attributes in the source subquery not used for aggregation or spreading will be used as grouping elements, so you need to be sure that there are no unnecessary attributes included in the subquery. One of the challenges in writing queries using pivot is the need to supply a fixed list of spreading elements to the pivot operator, such as a specific order year that we are using here. Let's execute this query and see what the results will look like. Let's open a new query and paste the query that we just saw and click on Execute. It will display the category, and all the years are displayed as columns, and the quantities are aggregated using the sum function and are displayed against each of the categories. Let's also do a simple select from the category quantity year view to compare the results. Copy and paste it here. Click on Execute. As you can see, the values here are summarized and are displayed using the pivot function. The pivot function made the data more readable and user-friendly. And when using the pivot function, it determines the grouping based on those columns in the input table which are not used for aggregation or as spreading elements, so you don't have to explicitly mention the group by clause. In this case, since we are using the order year as the spreading element and the quantity column for aggregation, the pivot function uses the category column to group all the data by. Now that we have learned how to pivot data, let's see how to unpivot it. Unpivoting data is the logical reverse of pivoting data. Instead of turning rows into columns, unpivot turns columns into rows. This is the technique useful in taking data that has already been pivoted and returning it into a row-oriented tabular display. When unpivoting data, one or more columns are defined as the source to be converted into rows, and the data in those columns is spread or split into one or more new rows depending on how many columns are being unpivoted. To use the unpivot operator, you need to provide three elements: source columns to be unpivoted, a name for the new column that will display the unpivoted values, and a name for the column that will display the names of the unpivoted values. And just like the pivot operator, you will define the output of the unpivot table operator as a derived table and provide its name. Let's take a look at this example. Let's say we want to unpivot all three columns 2006, 2007, and 2008. If you use the unpivot function, the data will be displayed as shown here. Each order year value will be copied into a new row and associated with its category value. For each intersection of the category and order year, a new row will be created. Any nulls will be removed in the process, and no rows with nulls will be created when you're using unpivot. Now that we have learned about pivoting and unpivoting data, the next question is, if we pivot any table and unpivot that table, do we get our original table back? When we pivot the table, we use aggregated functions. So when we use these aggregated functions and the data is aggregated, it will not be possible to get the original data back. Let's use the same example that we saw before to demonstrate this. Let's create a view using the query that we just saw and call it pivoted category sales. Select the query and click on Execute. Let's refresh these views. Okay. Now that we have our view, let's do a simple select category quantity order year from pivoted category sales using unpivot quantity for order year in 2006, 2007, and 2008. As unpivot. Let's click on Execute. As you can see, now we have the detailed rows for each of the categories and the order years. Now that we have seen how to unpivot data, let's see if we can pivot a table, unpivot the data back, and produce the same results as the original data. Let's open a new query. Let's expand the tables. And let's do a simple select from product test table. Click on Execute. And as you can see, there are two values for the product wedge for the customer Kate. Now let's pivot the data and see what the results will look like. Let's do a simple select customer veg, soda, milk, from select the customer, product, and quantity columns from product test table, and let's call it up, and let's pivot using the sum of the quantity for product in all the different kinds of products as pivot. Let's order it by customer. Let's select that query and click on execute. And as you can see, the veg category for Kate came up to 5. Let's unpivot this data and see what the results will look like. Let's do select customer, product, and quantity from the pivoted data, and let's take this order by off and call it P and use unpivot quantity for product in all the categories. As unpivot. Let's execute this query and see what the results will look like. Let's execute both the queries and compare the results. Click on execute, and as you can see, in the initial data, Kate had 2 rows for the same product category, which is 2 and 3 for quantities, and in the unpivoted data, you can see that Kate for the product veg has only 1 row. This shows that we cannot get the original table back if the aggregate function was applied on the data. We can only get the original table back if the aggregate function was not applied on the data, or data was in such a form that aggregate function might not have made any difference. So far in this module, you've learned how to use pivot and unpivot functions to change the orientation of the data. In the next lesson, you will learn how to use the grouping set subclause of the group by clause to have multiple groups in the same select statement.